example, I want to explain the portion of your project that is going to be dealing with applications in linear equations. And you should see a graph similar to this in your assignment. And I just want to walk through the graph and make sure that you are clear on what every piece of information that we are providing to you. So in this graph, this is describing that in 1960, the United States generated 87.1 million tons of solid waste and recovered 3.78 million tons. So when you look at this graph, I know you've studied linear equations by this point in ALEKS. This is our x-axis, and on the x-axis, these numbers, the 10, 20, 30, and the 40, are representing the number of years since 1960. So when x is 0, that is what we are equating to 1960. At 10, imagine adding 10 to 1960, so that would be the year 1970. 20 would be the year 1980. 30 would be the year 1990, and so forth. So as you see these ordered pairs along the line that goes with the amount recovered, the 0, 3.78, 0 represents the year 1960. 14 would be the same thing as taking 1960 and adding 14 years, so that would be 1974. And 35 years from 1960 would be taking 1960, adding 35, so this would represent the year 1995. On the y-axis, this represents the solid waste in millions of tons. So again, this is the year that it occurred, and this is how much waste occurred during that year. So let's interpret the green line again, which is the amount of waste recovered. So this ordered pair of 0, 3.78 is saying in 1960, which is what we've correlated to 0, 3.78 million of tons of waste was recovered. In 1974, we are saying, because the y value here of my ordered pair is 11.8, that means 11.8 millions of tons were recovered. And in 1995, we're saying there were 23.9 millions of tons of waste recovered. So the ordered pair is telling you the number of years since 1960, and the y value in the ordered pair is telling you the amount of solid waste in millions of tons. So the questions that you're going to answer, you'll be able to do that by using these ordered pairs for each of the lines. Now the pink graph here, or this pink graph, represents the amount of waste generated. And you will follow that same process of looking at the ordered pair. The first value, the x value, that's my first variable. That's telling me the number of years. So again, 0, 1960, 14, add 14 to 1960, so that's 1974, and then adding 35, 1995. And then these are the corresponding amounts in millions of tons for the amount generated. So that would be in 1960, 87.1 millions of tons generated. In 1974, 131.1 millions of tons generated. And in 1995, that would be 197.0 millions of tons generated. So some of the other questions are going to ask you about, well, which one of these occurred faster? For that question, we want you to look at the slope of the line. And as you know, you've been studying, the slope is the steepness of that line. Algebraically, you have been given models of these two lines in the form of an equation, and both of your equations are in slope-intercept form. So G is the equation for the function for amount generated. R is the function for the line amount recovered. So, and when I say slope-intercept form, that means my line is in the y equals mx plus b format, where m is the slope of my line, and b tells me the y-intercept. 0b. So both of these equations are already given to you in our slope-intercept form. So when you compare these two lines and talk about the slope and which one has the greater slope, we're simply asking you to compare their slopes. And the slope of the amount generated is 3.14. The slope of the amount recovered is 0.576. So in your comparison, we want you to specifically discuss their slopes, how their slopes are different, and use that in that context of answering this question. Secondly, in this part of the application, you're going to be asked to find the amount generated, and we will give you the specific value to substitute into that equation. So if you're asked about a year different than 1960, 1974, and 1935, you would simply figure out how many years that has been since 1960, and that is what you would substitute into your equation to solve. So for example, let's say you were asked to find the amount generated in the year 1980. And I'm going to write down here in the lower corner so that we have, and I'll use a different color so we won't get, we'll can keep everything nice and organized. So if we're talking about the year 1980, we know that that is 20 years from 1960, correct? So we would use x equals 20, because again, our benchmark is 1960 is what represents 0. So I believe I said amount generated, so we would take the equation for G, and where there is an x, which represents the number of years since 1960, that's where I would substitute 20, and then we will solve this equation. And grabbing a calculator, we will find what 3.14 times 20 is, and that is 62.8 plus 87.1. So that means that there were 149.9 millions of tons of waste generated in the year 1980. So again, I hope this example has first helped you to interpret the graph that you're given in the application and help you make sense of the ordered pairs and how you can answer different questions either specifically related to the ordered pairs on our graph, or if we ask you to calculate a different year that wasn't given on the graph but that you can compute by finding the value of x and substituting that into the problem. Please let me know if you have any additional questions.